Okay. Hello, my name is Artem Nosov. We present a project waste-free production. The project was also carried out by Nikolai Fanov, scientific mentor, Ilya Petsov. The problem is in large waste after cutting metal corners on a milling machine. The waste is represented by scraps. At the factory, the nesting plan is made manually in cut compass. The slide shows the causes of waste. Nesting plan can be optimized by changing the arrangement of details, the set. The solution is in the reduction of the space between parts. We took the paths of automated placement optimization. And we have chosen our heuristic algorithm and computer simulation as our methods. The first will grant us the ease of understanding. The latter will let us make use of the ability to conduct physical experiments close to real. On the left, there is the traveling salesman problem, to which the greedy heuristic are applicable. On the right, you can see a computer simulation of a process of collision of a car with an obstacle. Renaud?
We are all familiar with the law of gravity. In the Earth's gravity field, objects tend to fall to the ground. Take a look at the slide. Gravity has collected a cloud of gas and dust into the solar system objects, so that the matter has taken up minimum volume. Similar things happen on Earth. For example, if you throw several different shaped objects into a box, then shake it, they will take up less volume than if you just put them into a static box. This case can be displayed on a 2D box. The essence remains the same. The next example confirms our theory. A compaction factor of crushed stone can be equal to 1.2. The parameter indicates the rate of compression after transportation. For example, if we order 12 cubic meters of crushed stone, we may get only 10 cubic meters because of compaction. This can be recreated at home by shaking a jar of nuts. After shaking, the level of nuts in the jar decreased by 40 millimeters. We used Python and Pythonic 2D physics library PyMonk. Under fixed initial conditions, experimental results are determined by the object throwing order, so a large number of experiments are required to find an optimal option. This slide shows dependency between the number of experiments and the filling percentage. It's clear that the larger the design percentage, the more experiments should be conducted.
We have created a script for construction the optimal nesting plan. Out of hundreds of thousand experiments, the program increases the percentage of occupied space by 6%. Now demonstration. As you can see, first we put figures into the box, then compress them. We get a new version of a nesting plan as a result. We are going to add a selection of parts, input of sheet dimensions, return of the result in the form of a cut compass file. We plan to optimize the algorithm, namely to reduce the operating time to 2 minutes, to increase the percentage of filling by adding processing steps and using patterns. Thank you for your attention.